Good day and thank you for the opportunity to present. I am UMMUL HANAN MOHAMAD and today I'll be presenting my work, titled Enhancing Early Communication in Children with Autism through a user-centered augmented reality object recognition application. So this research was conducted at UKM and it focused on how we carefully design AR technology that can support early communication behavior in children, especially those with autism spectrum disorder. Okay, so why do this problem matters? Okay, so children with autism often experience significant challenges, especially in the early communication. So this includes difficulty in recognizing objects, understanding their functional meaning, and also initiating communication. So such challenges affect not only the verbal development, but also the daily learning routines and also the social interaction. Okay, so while visual supports are commonly used, many existing approaches actually are still limited in terms of interactivity and also engagement. Okay, so what's missing in the current solution? So we do have traditional tools like static images or picture-based systems that are helpful, but these tools they often lack multimodal interaction. So on the other hand, so many existing AR applications are not designed especially or specifically to cater for children with autism. Okay, so what happens is that most of these applications are they frequently overlook sensory sensitivity, the cognitive load, and also the actual learning behaviors. Okay, so this actually creates a clear gap. So there's a need for a user-centered AR solution that is designed specifically for ASD learners. Okay, so to address the gap that I've mentioned earlier, the study has three main aims. Okay, first is actually to design an AR object recognition application using a user-centered design approach, and then the second one will be to evaluate its usability through a direct observation of children, and also the third one is to gather quantitative usability feedback, especially from parents. So this aims is actually comes from a research question. So when AR is designed using a user-centered principles, does it actually supports communication behavior in ASD children? Okay, so through this research question and also through this research aims, we hope to actually contribute, okay, in providing practical design insights and then perhaps having an empirical usability evidence and also inclusive learning perspective that will actually guides or become an evidence. Okay, so the foundation of this work actually combines three elements. It's centered across it is centered to user-centered design, okay, but it's grounded especially in the design towards sensory-friendly interaction, predictive navigation, iterative feedbacks from parents and also educators. Okay, so our the foundation for the study or the design of this research it includes first the user-centered design. Okay, so user-centered design will actually ensure that the system is shaped around the real user's need. Second, we are working on AR. Okay, so which allows digital cues or hints to be overlaid into real world objects. And also the third one we are focusing on the learning characteristic of children with autism. So when we integrate these elements, the application aims to be both educationally effective and also sensory friendly. Okay, so the key idea in short is the design must actually adapt to the children and not the other way around where the previous works has done that mostly. Okay, so what the AR system or AR application actually does is that the prototype actually uses a mobile device, okay, It recognizes everyday objects, and then when the object is detected, the application display a 3D animation on what the object function is, okay, and then an object label, and also the auditory or the audio cues, and also the functional explanation, very short one. Okay, but importantly, the interface is intentionally simple. Okay, um, minimal visual clutter. The animation speed is moderate, and then we have a predictable navigation. This is to reduce the sensory overload, which is a problem or a challenge to the children with autism. Okay, so this study employed quantitative feasibility study. Okay, we evaluate the prototype using direct child interaction sessions. Okay, structured observation, which is like SOB's questionnaire, and also parents usability ratings. So we mostly focus on what children do and not what the systems claim it to do. Okay. So the reasons why there's a direct observation of children, because these children are not like the normal children. Okay, we can't really interview them or ask them questions. Okay, so a direct observation is much more appropriate in this kind of cases. Okay, and then only we get feedback from the parents. Okay, so the focus of this paper is actually more strictly towards measurable usability outcomes, okay, rather than the qualitative interviews. Okay. In terms of participants and settings, okay, we actually use real users, real setting where this study is actually conducted in Autism Research Lab UKM, where they have the intervention sessions. It involves around 5 children with ASD, aged from 4 to 10. Parents are the secondary evaluators, and each child interacted individually with the prototype in a very short guided session. Okay. Okay, so this is the table one, which summarizes the child's interaction outcomes, okay, across 8 dimensions that we measure. Okay. It's from the I mean the tool for evaluation will be the ISO 924111 usability framework. Okay, so 8 dimensions are actually observed. This include attention, interaction level, communication attempts, emotional response, and also the task completion. So this dimension actually allows us to systematically capture how the children engage with the AR application without imposing any formal testing pressure on them. Okay, because these are children with autism. Okay, to summarize what is shown in table one, okay, so table one actually showed how the user-centered AR applications support attention, interaction, and communication in children with ASD, while also clearly highlighting that there's a need for adaptive design to accommodate individual differences. Okay, so that's about the children interaction. Okay, we also observed that the engagement was positive. Okay, but it's not uniform, which means that the results is not it's not that each child have the same results. Okay, okay. So some children have showed strong attention and communication. Others required repeated prompts and also assistance from the teacher or the facilitator, or and then one child showed signs of digital fatigue. Okay, so you can see that the result actually showed variation, but generally it's a positive interaction patterns. So the key insights that we actually can obtain from here is that usability actually depends on the baseline readiness and whether the child is ready for intervention using AR application. Um, okay, so that's the results from the observation of children. Okay, for the parents, usability results, you can say that the parents actually evaluation actually strongly supported the observations. Okay, so there's a high ratings for satisfaction, communication support, and sensory compatibility. With the overall mean usability score around 4.42, but there's a lower rating for error handling. Okay, whereby the children needed the adult help. Okay, so there's something that you can actually improve. Okay, and the parents validate what we have observed in a way that um although the error handling received the lowest score, so it suggests that we do need to have a clearer feedback, okay, when the children makes mistake. So that's something that can be changed or improved in the application. Okay, okay, so when combining both data source, which is from the observation and also from the parents' visibility feedback, we see that the application actually works particularly well for children with strong baseline attention and also communication readiness. But at the same time, the children who require more prompting would benefit from clearer guidance, okay, adaptive scaffolding, and then perhaps an improved error recovery. So these findings are crucial, okay, for refining inclusive educational technologies. Okay, in conclusion, the study actually demonstrates a user-centered AR application can actually effectively communicate or support early communication behavior in children with autism. So the results really highlighted that the importance of sensory friendly design and also stakeholder involvement when we are designing applications for specific groups of people or children. Okay, in terms of a practical perspective, this book actually offers useful guidance for educators, therapists, and also maybe developers that design technology or AI applications for special education contexts. Okay. And then for future work, will involve perhaps a larger scale testing and also longer term evaluation to assess the learning retention. And the other plans will be to incorporate adaptive difficulty levels, perhaps you improve on the error handling mechanisms and also the progress tracking features that is suggested perhaps from the parents and also the teachers. So as a conclusion, inclusive technology starts with inclusive designs. Okay, so that will be all for my presentation. Thank you for listening.